please follow along on the bottom of page 2 in your pink packet as I read. So this section is about the distributive property. Swimming pools are sometimes divided into sections that are used for different purposes. A pool may have a section for swimming laps, and a section for diving, or a section for experienced swimmers and a section for small children. Below are diagrams of pools with swimming and diving sections. The dimensions are in meters. Write 2 different but equivalent expressions for the area of each pool. Write 2 different but equivalent expressions for the area of each pool. Since we're going to be working with area, and you can see that all of the swimming pools consist of rectangles, we have to make sure we remember how to find the area of a rectangle. And the area of a rectangle we find by multiplying the base times the height. And the commutative property of multiplication tells us that we could multiply the height by the base. The order in which we multiply does not matter. So let's look at the first pool. This first pool has a large section that's probably for just regular swimmers, and then a small section for diving. One way to find the area of the entire pool is to first find the area of each part, the swimming section and the diving section. We just use base times height or height times base. So for the swimming section, the blue rectangle, the base is x, the height is 30, so we just multiply 30 and x and get 30x. For the diving section, the base of that section is 10. The height is also that 30. We multiply 30 times 10, or 10 times 30, and we get 300. So one way to express the area of the whole pool would be to add those 2 smaller areas together. So we could say that the area of this pool is 30x plus 300. Another way to write an expression for the area of the pool is to think about the pool as just one big rectangle. If we think of it that way, then the height of our rectangle is still 30, but the base consists of the x and the 10, and together that makes an x plus 10. So the height of our rectangle is 30, the base of the rectangle is x plus 10, so we can write another area expression by multiplying 30 by x plus 10. And all we're doing is multiplying the height times the base, and we get this expression for the area. Now let's look at number 3. We're going to jump to number 3. So if we take a look at pool number 3, we can see it's actually split into 4 sections. We have this square-looking section, and then we have some smaller rectangles. So again, we're going to write 2 different expressions for the area, and one way to do it is to fill in the area of each part. So if we look here in this top square, its height is x, its base is also x, and x times x is x squared. If we look at this bottom rectangle, its height is 2, its base is x, and 2 times x is 2x. If we look at this rectangle up here, its height is x, its base is 3, and x times 3 is the same as 3 times x, and that's 3x. And then finally, our little rectangle down here, it has a height of 2 and a base of 3, and 2 times 3 is 6. We just get a nice number. So we can write an area expression by just adding up all those small areas. So I can just write x squared plus 3x plus 2x plus 6. And we'll talk more about this later, but that 3x and 2x can actually be added together, and we can write x squared plus 5x plus 6. That's one of the expressions for the area. The other way to write an expression for the area is to look at the entire rectangle all at once. If we look at the entire rectangle, the height of the rectangle is x plus 2, and the base of the entire rectangle is x plus 3. So another area expression would be to just multiply the height and the base together, which would look like x plus 2 times x plus 3. So our first area expression came from adding up the areas on the inside, and our other area expression came from multiplying the entire base by the entire height. So now I'd like you to try to work on number 2 and number 4.